Okay, so I have this improper integral. The integral from 0 to 3 of 1 over 1 minus x squared. Again, how do I know that's improper? Because I've got a discontinuity here at x equals 1. So if you were to sketch this, our limits of integration go from 0 to 3. This graph has an asymptote at 1. Okay, so there's a discontinuity. So what that tells us is that there's a, so this is an improper integral. Okay, and so we're gonna break this up and do the treat it as the limit as b goes to 1 from the left side. Again, over here in my little diagram, I didn't draw the curve, but we can kind of ignore it for now. So we're gonna put a b here and do an integral from 0 to b, and b is gonna approach 1 from the left hand side. Sorry, I think I made my, kind of like put my 1 in a strange spot. 1 is there. So here's b. And so like b is going to, right, if we zoom in, b is going to go towards 1 over here where we have our discontinuity. So it's coming from the left. And so it's the limit of the integral from 0 to 0 to b, as b goes to 1 from the left of this integral. And then we're going to do the limit, we're going to maybe use a different letter. So we're going to integrate from a to 3, and then we're going to push a towards 1 coming from the right-hand side. So that's going to be added to the integral from a to 3. Oops, but my limit. Sorry. Plus the limit as a goes to 1 from the right-hand side, or the positive side, the integral from a to 3. So what to do now is to do these one at a time. Don't do them both together, because if one of them is infinity, then the answer is divergent, okay? So you don't try to do both the purple and the pink at once. Just stick with one, because the chances are you might get an infinity, which allows you to just conclude divergent. Okay, so this is going to be, let's actually, so I don't have to keep writing limit. Let's just take this expression. We apply the fundamental theorem. So the antiderivative of, let's call this 1 minus x to the negative 2. Okay, its antiderivative would be, let's see, add 1 to the exponent. Okay, and again, if you take that derivative, you'll get negative 1 minus x to the negative 2 times negative 1, which would cancel out. So I think this is good. This is our antiderivative. Okay, so this would be now the limit as b goes to 1 from the left of the expression 1 over 1 minus x evaluated from 0 to b. Okay, again, this is my antiderivative rewritten like that. Okay, so let's see what happens here. So this is now the limit as b goes to 1 from the left of 1 over 1 minus b minus 1 over 1 minus 0. Okay, so like this is just 1, but the question is what's going to happen here. Okay, so as b goes to 1 from the left, you can think numerically, like what kind of a number are we getting here? Well, pick a number really close to 1 on the left. How about 1 minus, like 0.999? So that's 1 divided by a really tiny number. I guess specifically it's this. That's 1 divided by 1,000th, which is 1,000. Okay, and the closer b gets to 1, the bigger this gets. So if like the smaller this gets, the bigger this gets. So that means this is going to be, this limit here is going to infinity. So infinity minus 1, that means diverging. So we select divergent. Notice I didn't even need to go address this. Okay, as soon as one arm of a problem like this is infinity, you can just assert. So if we gotten a number like, 1/2, then we'd have to go do the other one and see if we also got a number, and then we would add those numbers together. But in this case, we got infinity, so we select divergent.